Hello everyone, I am Dipansh Arora and I welcome you back to my channel where we were discussing data analysis in Python, and in the previous video we finished with the pandas lecture series. In this video we will be beginning with data visualization, which is also a part of data analysis, and for this video we'll be looking at the library Matplotlib. So a brief introduction of Matplotlib is here. Matplotlib is a versatile Python library used to build static, animated and interactive charts or graphs. It is one of the most popular tools for visualizing data in the fields of data science and analytics. In this lesson, we will explore the fundamentals of Matplotlib, including how to create different plot types and customize them effectively. So the first thing that we will do is how to install Matplotlib, and you can do it by just writing an exclamation mark followed by pip install Matplotlib in your Jupyter notebook. I'll just select the kernel. While it takes some time to connect to my kernel, I'll actually write a sample dataset here. It has connected to the kernel, and now it has already, the Matplotlib library is already installed in my system, so the requirement is already satisfied. Another way to install the Matplotlib library is that you can go to your requirements.txt and you can mention Matplotlib here, and then rather than writing pip install matplotlib, you can write pip install -r requirements.txt. So it will read through all the requirements and it will install all the requirements. Whatever which are not installed will be installed in your system. Whichever are installed will show requirements already satisfied. Okay. So now I have created this sample data set, and now we'll be looking at a basic line plot. Now to create a basic line plot, first of all what we have to do is we have to import matplotlib.pyplot as PLT. So pyplot is a library inside Matplotlib which is very useful for data visualization, and hence we'll be using this library, and I have given the alias PLT. You can give any other alias as well, but the convention says that you use PLT only. If some other developers will be reading your code, then they will easily understand that okay, PLT means matplotlib.pyplot, and if you are coding for yourself, then why not go ahead, use zebra, horses or anything as alias. Now let's run this. Okay, so now let's plot this. To plot the graph, all we have to do is write plt.plot, and we have to pass our variables as parameters. And now you can see a beautiful plot has been plotted with all the coordinates plotted, and a line plot is created in front of you. Now you can label this graph as well. That is, if you want the x-axis to be labeled, you can say x label, plt.x label, and you can pass here any value. I'm writing x-axis. You can write plt.y label. You can pass any value. I'm writing y-axis, and you can give a title to the plot as well. plt.title. I'm passing here basic line plot, and then you have to do is plot.show. So now you can see that the y-axis has been labeled, the x-axis has been labeled, and you have the title of the whole graph, that is basic line plot. Now you can customize this line plot as well. Now to customize this, what we'll do is I'll first copy this data and I'll paste it here, and I'll plot it again. And now while plotting, I'll give some parameters. One parameter is color. You can change the color of the line to any other color. I'm changing it to red. When I run this, I get a red line here. Now there are other parameters as well. There is something called as line style. So by default it is a dash. So if I give a single dash here, the line style won't change. It will be represented the same way. But if I give a double dash here, the line will be represented with double dashes. There is another line style which you can try, that is dash dot, and now the line is represented with dash dot, dash dot, dash dot all over. Now to see what are the valid values for line style, just pass an invalid value. You get an error now, and in this error there will be supported values. So the supported values are dash, double dash, dash dot, colon, none, space, blank, solid, dashed, dash dot, dash dot, dotted. So I'll just give a colon here which will make it a dotted line. You can see that the colon has made it a dotted line. Now when you can change the line style, you can also change the width of the line. To change the width of the line, just write line width. You can give it as 3, and now the line has become thicker. I'll change the line style back to dash so that you can easily see the thickness of the line. Now there is something called as marker as well. Marker will point out all the coordinates that have been plotted, that you have given. I'll say O here, and O will give me these circles. I can also write star here, and I'll get these star markers. Now you can see that the markers are very small right now. Even with O, the markers were very small. They are not visible when we increase the line width. So if line width can increase, the marker size can also increase. And Python is a simple language. To increase marker size, just write marker size. I'll change it to 9. Now you can see that the marker size has increased. Now the markers are clearly visible. So this is how you customize a line plot. Okay. You can also copy it, view this graph in other ways, zoom it out, zoom it in, and you can copy it, save it. If you want to, you have the options. Now we'll look at something called as multiple plots in a single figure space. Now to do that, what we'll do is we'll actually define a figure space first. We'll say plt.figure, and we'll say fig size, and I'll pass the fig size as 9,5. Now when I run this cell, it has made the figure. You cannot see anything right now because there are no plots, but the figure size has been created. Now we'll make subplots here. So I'll say plt.subplot, and I'll say 1, 2, 1. I'll explain you what these values are. Plt.plot, and let's go with x, y, color is equal to green. So now you can see that the graph has been plotted here, and there is some space on the right. So why is there this space on the right? There was no space when we created this graph. This is because when you specify the figure size and then you say subplot, you actually say in how much space you want to divide it, in what way you want to divide it. So the first parameter of subplot is actually number of rows. So I have created one row. Second parameter is number of columns, and the third parameter is which graph you are plotting, graph number, first graph, second graph, third graph, or fourth graph. Now let's plot another graph here. Plt dot subplot, and 1 comma 2 comma second graph, I'll say plt dot plot x comma y comma color, not x comma y, actually y comma x comma color is equal to blue. Now you can see that in the same space I have two graphs. Now I can create more graphs as well in the same space. I'll show you that as well. So for that I'll copy this code, and along with that I'll also define another value, that is y2, and it would be 1, 8, 27, 64, 125. So I think that's enough. Now what I'll do is I'll create two rows and two columns. So first graph was x comma y, second graph was y comma x. Now let's actually create a third graph here, plt dot subplot, and 2 comma 2 comma 3 third graph, and I'll say plt dot plot x comma y2, and color I can change to yellow, and let's plot another graph, that is plt dot subplot 2 comma 2 comma 4, that is the fourth graph, and uh, let's plot this, and it will be y2 comma x, actually y2 comma x, and color I'll change to red. Now I can give titles as well to these graphs, as I have given them before. So now you can see in the same figure space, in the same space, four graphs have been created for me. So this is x comma y, y comma x, x comma y2, y comma x2, y2 comma x. So this is how you create multiple plots. Now let's look at something called as a bar plot. So a bar plot is useful when you have categories, data in categories. So you must have used a bar plot in your elementary classes as well, where you plot the data in the form of buildings, or you can say blocks, and is one of the most common visualization methods to represent data. So let's actually plot a bar plot. So since we have to first give categories, I'll give the categories as A, B, C, and D. Let's go with five categories, E, and I'll give the values as, okay, I have to take random values, 4, 8, 6, 5, 9. I think these are some random values. Now to make a bar plot, all you have to do is write plt.bar, pass your categories, pass your values, and if you want to change the color as well, and change the color to purple, and when I'll plot it, here is a beautiful bar plot with all the categories, and all the categories are mentioning the size of the buildings, are mentioning the values. So this is how you create a bar plot. Now let's look at something called as histograms. So histograms are used to represent the distribution of a data set. They divide the data into bins and count the number of data sets in each bin. So when you have continuous data, then you have to use histograms. So let's actually make a histogram, and for that we'll take a sample data. I'll create a sample data right now. That is 1, 2, 2, 3 threes, 4 fours, and 5 fives. Now let's actually create our data. Plot dot hist, and now you have to pass data, and I think that's it. If you want to change the color, you can change the color as well. uh, and bins, number of bins actually has to be provided, so bins will be 5, of the data to be plotted in 5 bins. So now you can see that here I have what the bins have been created as. Like the bins are 1 to 1.8, 1.8 to 2.6, 2.6 to 3.4, 3.4 to 4.2, and 4.2 to 5. So you can see that there is one value in 1 to 1.8, and two values in 1.8 to 2.6, three values in 2.6 to 3.4, four values in 3.4 to 4.2, and five values in 4.2 to 5. Now this is not very intuitive because the edges are merged together, so it's not very intuitive. So what can we do is we can customize this as well. So let's do some customizations, and we'll change the color to orange, and you can change the edge color as well. So I'll change the edge color to black. Now it becomes very intuitive. Now you know that it is exceeding 1.5, so it's around 1.8, this is 2.6, this is 3.4, this is 4.2, and this is 5. So this is how you can create a histogram. Now let's look at something called as a scatter plot. So scatter plot is actually useful when you have multiple values for a single data, like for x you have multiple y values, for y you have multiple x values. But for the time being I'm showing you a very simple scatter plot. Like I'll be using very simple values 1 2 3 4 5, and y is equal to 2 comma 3 comma 4 comma 5 comma 6. And now to create a scatter plot you have to write plt dot scatter. You have to pass your values x comma y. You have to pass the color. Color will be, let's say, orange only. I like orange. And marker will be an x. So this is how you can create a scatter plot. So these coordinates have been plotted on the graph. Now after scatter plot, we'll be looking at something which is most commonly used in companies and in PPTs and gives us really good insights, and that is a pie chart. You can actually get very good insights from a pie chart, and you must have seen that uh, companies are very keen to use pie charts in their PPTs. So let's actually create a pie chart. Pie charts. Now to create pie charts, we need labels, and I'll give the labels as A, B, C, D. Let me just, yeah, now it's fine. Then you want sizes of the labels. So I'll go 10, 20, 30, 40, and I can also give color. So I'll go gold, yellow, green, light coral, some very weird colors, light sky blue. Now let's make a pie chart. To make a pie chart, all you have to do is write plt.pie, pass your sizes, and pass your labels as labels. Labels is equal to labels, and you can plot it. When you plot it, you can see that by default it has already given some colors like red, green, orange, and blue. I can change the colors as well. Colors is equal to color. So now the colors have changed to what I have specified. Now there is another thing. Before introducing that thing, I'll actually tell you how to mention the percentages in the pie chart. So right now you cannot see what percentage is. I mean, you can see the representations, but you cannot see the numbers. What percentage is what is representing? What is representing what percentage? So you can just go auto PCT and you can say percentage 1.1 F percentage. And now when I run this, I'll get percentages as well. So what does this 1.1f means? It means one number must be there before the decimal and one number must be there after the decimal, and the other, this percentage and this percentage is to match the other numbers, and this percentage is to print the percentage sign. So now I get 20%, 10%, 40% and 30% written. Now there is another attribute, another parameter which you can give here, which is explode. Now I'll tell you what it is. First I'll just give the values. Now here I'll just give another comma here and say explode is equal to explode. Now when I do this, it automatically shifts the A pi by zero point 0.2 value. So the A pi gets a little outwards, comes a little outwards. So this explode, actually what it does is that it pushes a particular value a little outwards. Since I changed the first value, that is A to zero point 0.2, that's why it has pushed the A pi to outwards. And if I change the other values as well, like if I mention every other value to be zero point 0.2, then all the values are like now this, broken down. So this is how you create a pie chart. Now we have learned a lot of things. Now we have learned scatter plots, we have learned histograms, we have seen bar plot, we have seen line plots, and we have seen customization of line plots. Now let's do some real world data analysis. And before that, I can show you another parameter, that is shadow. If you say shadow is equal to true, then all your plots will have this shadow. It just makes it look a little better, makes it look a little 3D. So this is how you make a pie chart. Now let's do some real world data analysis, and for that I have this sales data.csv, which has a lot of values and is a very useful file. So I'll be using this file to do some real world data analysis. Now let's get back to our code, and first let's import pandas as pd and run this cell. Now what we'll do is we'll do pd dot, okay, we'll say df is equal to pd dot read underscore csv, and we'll say sales underscore data dot csv. So now our data frame is defined. Now let's print the data frame. Actually df dot head, we just want first 5 values. So now you can see the first 5 values of the data frame. Now let's actually do some data analysis with this. So I want that the product category, first actually let's group by the product category and find out how much sales each category has made. So to do that, I'll say sales by category is equal to df dot group by, and now here I'll say product category, and now I'll take total revenue and we'll do a sum here. Now let's print sales by category. Sales by category. So now you can see that beauty products have sold this much, and sports have sold this much, electronics this much, home appliances this much. So now let's actually plot this sales by category. To plot this, what we'll do is we'll write sales by category dot plot, and here we'll say kind is equal to bar. Now you can see a beautiful bar plot has been printed. You can also change the color of this, and I'll change the color to teal. Now it's looking much better. So products, so most sales were of electronics sold the most, and appliances the second, sports the next, followed by clothing, followed by beauty products, followed by books. Well, that's very obvious. Books are being sold the least, electronics are being sold the most. Ah, okay, now let's do something else. Let's actually plot using these dates. uh, to do that, what I'm gonna do is hmm, sales by date, and we'll say df dot group by date, and we'll take total revenue here, total revenue, and we'll say sum. Okay, oh, mentioned data rather than date, and I have to see whether date is capital or small. D is capital in date, so that will also give an error. So let me just change it. Now it won't give an error. Now it runs perfectly. So now when I say sales by date and I run this, I get these sales by date. So let's actually do one thing more. We'll say reset index. Yeah, now you get it in the form of a data frame. Now let's actually plot this sales by date. So to plot this sales by date, what we'll do is we'll say plt.plot, and again we'll give the x and y values here. So the x value is sales by date, and the column name is date, and y value is, let me just, sales by date, and that will be total revenue. Total revenue. Oh, where did it go? Total revenue. Now, this will take some time, but now you can see that okay, it's not very intuitive because the dates are way too many. So still you can see that at some point there were sales peak, and at some point sales were very low. So it's not very intuitive, this plot, but you get the idea on of how to plot these on real world data sets. So this is it from my side. I will see you in the next video. Thank you for watching. If you liked the video, press the like button. Subscribe to the channel if you are new. A Python refresher course is also coming up next week. So subscribe to the channel and keep on following if you don't understand Python. And comment your doubts if you have any from this video. And thank you for watching. I'll see you in the next video.